Right, okay. So, good afternoon for you all. Today, I'm starting organic therapy sessions. So, what does mean by this organic therapy? What is this? So, organic therapy means here my intention is to discuss organic reactions with you, right? Remember, normally in our syllabus, approximately there are more than 50 organic reactions if you consider them separately, right? So, therefore, try to understand. The thing is, most of the students can't remember these reactions, right? We are learning a lot of organic theories, lot of things. There are 4 units, you know, that unit number 7, 8, 9, 10 in our syllabus. They are organic chemistry theories, completely theories, basic concepts of organic chemistry: hydrocarbons and halohydrocarbons, oxygen containing organic compounds, and the last topic is nitrogen containing organic compounds. So under these 4 topics, under these 4 units, we have to discuss a lot of theories. Under those theories, we are learning a lot of reactions. So now the issue is, most of the students can't remember these organic reactions, right? We know that there are several organic compounds. In theories, we have learned that we have to learn 15 types of organic compounds, separate compounds. Minimum 15 compounds are there. So there are so many reactions related to these 15 reactions, organic compounds. So how we can remember these things? Remember, if you can't remember these organic reactions, so the main disadvantage is in the examination, you can't do the organic conversion that they are giving, right? They are giving some organic conversions to do. If you consider the last year paper, actually last year paper organic conversions are very easy, 23. But we don't know in your examination, 24 examination, what kind of organic conversion you will get. So you have to prepare for it. So in order to prepare for that one properly, so you must have a good practice of organic reactions, right? My intention is not discuss to organic conversions. You can practice organic conversions, but I'm practice you to do these conversions in a different way by practicing the reactions, right? So this is not organic theories, okay? As I mentioned you, in this organic therapy sessions, we are going to discuss, we are going to practice organic reactions, right? Okay, let's move for the topic. So this is the session 1 of organic therapy. Session 1. First of all, let's discuss some basic things related to our reactions. So when you consider the basics, what are the basics actually you should know before we go for the reactions, right? First of all, you should be able to identify any kind of organic compound. That is enough for the organic reactions, right? In order to practice the organic reactions, you should be able to identify, first of all, what is this organic compound. Then only we can go for the reactions. So let's go for the quickly. Let's go for the organic compounds that we learn. Recall organic compounds, types of organic compounds that you learn. First of all, we can go for the alkanes, right? How we can identify alkane? What is the functional group of alkane? We know that simply carbon-carbon single bonds which are connected to hydrogens are considered as alkanes. Examples are methane, ethane, propane, butane. Likewise, we can go for the alkane series. You have learned that one in theories, right? So this is alkane. If you go for the second type of organic compound, the second one is alkenes, right? Alkenes. What is the functional group of alkene? Functional group of alkene is carbon-carbon double bond, and these carbon atoms are connected to hydrogen atoms, right? Alkane, alkene, and alkynes, these 3 compounds are hydrocarbons. We consider them as aliphatic hydrocarbons, right? You have learned these things. Third one is alkyne. Alkyne is carbon-carbon triple bond in this way. Fourth one, let's move for the fourth one, alkyl halide. the first reaction that we are going to learn today is related to alkyl halide. So how do you identify alkyl halide? So what is an exactly alkyl halide? Alkyl halide means we have carbon atom. For the carbon atom, halogen group is connected. Halogen atom is connected. So therefore, X can be mostly chlorine, bromine, and iodine. Right? So those are considered as alkyl halides. Alkanes, alkenes, alkynes, alkyl halides. Let's go for the fifth one. Fifth one. First of all, you should know these types of organic compounds, right? By looking at their functional group, you should be able to identify them, right? If you see double bond, you should know that is an alkene. If you see triple bond between two carbon atoms, you should know that is alkyne. If you see halogen atom directly connected to the carbon atom, then you should know that is alkyl halide. Next one, alcohol. Ethanol, methanol, propanol. How do you identify alcohol? Alcohol can be identified when OH group is connected to the carbon atom in this way, right? So that is an alcohol. Sixth one, let me consider ether. Ethers. Ether is also a type of organic compound that we learn. So ether, we have discussed these things, but I want to remind these things again before go for the organic reactions. These things are very important, right? So only knowing the type of organic compound is enough to discuss the reactions. Let's see. Ether, how do you identify an ether? Ether means oxygen atom, a centralized oxygen atom surrounded by some alkyl groups. Here we can have CH3, methyl group, and CH2CH3, ethyl group. If there is only one carbon atom, we consider that one as methyl. If there are two carbon atoms in this alkyl group, we consider that one as ethyl. Right? We have learned these things, right? One means meth, two means eth, three means prop, four means but, and five means pent, hex, hep. Likewise, we have learned these things, neither, right? So oxygen is central atom surrounded by alkyl groups. Then this is ether. Let's move for the next one. Seventh one. Seventh one, aldehyde. How do you identify an aldehyde? Aldehyde is always representing carbonyl group, and the hydrogen atom is connecting to the carbon atom, C double bond OH. For example, CH3, C double bond OH, right? Two carbon atoms are there. Therefore, this is known as ethanol, simply, right? The way that aldehydes are naming, the way that names of aldehydes are ending is L. The suffix L should be added there. So therefore, that is ethanol. Very easy, right? Aldehyde means what is the functional group? C double bond OH. First of all, you have to remember this functional group, right? Alcohol means OH group is there. Ether means oxygen atom is centralized, and surrounding groups are alkyl groups. Aldehyde means C double bond OH. Then how do you identify a ketone? Next one is ketone. Ketone means just carbonyl group, C double bond. And here we have some alkyl groups. It cannot be hydrogen, because if it is hydrogen, we have to consider that one as an aldehyde, right? Number 9. Ninth one, let me consider that one as carboxylic acids. Yeah. Carboxylic acid. How do you identify carboxylic acid? Carboxylic acid can be identified using this functional group C double bond OH, right? C double bond OH. If you can see C double bond OH functional group, definitely that should be what? Carboxylic acid. So for example, acetic acid, ethanoic acid, CH3C double bond OH. Acetic acid is containing in vinegar. We know that one. Carboxylic acid, right? So you take a book, right? Writing book, and write down these things. These things are simple things. We have learned these things in theories, but we are revising in order to do the reactions. Carboxylic acid. Let's go for the next one. Number 10. Carboxylic acid. The next one is ester. How we can identify esters? What are the functional group of esters? Functional group of esters are C double bond O, right? A single oxygen atom is connecting the carbon atom to a single bond. This is ester. 11th one, amine. How we can identify amine? Amine means carbon atom is connected to the nitrogen atom, right? It can be primary amine, secondary amine, or tertiary amine. So likewise, when carbon is connected to the nitrogen to a single bond, we consider that one as amine, right? Commonly say that amine means NH2 groups, but it's not compulsory to be a NH2. It can be NHCH3. Likewise, alkyl groups also can be connected. So this is amine. Next one, 12th one, amide. So what are amides? Amide means carbon, oxygen double bond, and here nitrogen is connected. For the carbonyl group, when nitrogen atom is connected, we consider that one is amide, right? Esters, amine, amide. Next one is also very important. What is it? 13th one. So this is acid halide. Acid halide. Acid halides are considered as C double bondo X, right? So this X can be mostly chlorine or else bromine. So these are acid halide, right? Look at these things. So these are the organic compounds that we have to learn. And sometimes in the conversions, we are using these compounds also. Therefore, we have to learn them. 14. Cyanides. Cyanides means actually we know that carbon, nitrogen. And the 15th one is nitro compound. Nitro compounds. Nitro compounds can be identified when NO2 group is connected to the carbon atom or any kind of organic group. So these are the 15 types of organic compounds, main compound types, the types of organic compounds we learn. So you should know that one. You should know the functional group of the compound, and you should be able to identify the compound by looking at the molecular formula or the structure, right? So these are the basic things that we need. Very easy. Now directly we can go for the reactions. Okay. Do you have any doubts regarding identifying organic compound? Anything? These things are very easy. Okay. You have learned these things in organic theories. So therefore these things are not that much difficult. Try to understand. Right, okay. It seems you don't have any doubts. Then let's move for the organic reactions. Okay, right. Now students, remember, when you consider organic reactions in our syllabus, I'm going to categorize them under 4 parts. If not, that will be very difficult to discuss these reactions because so many reactions are there. So, our topic, organic reactions.
அப்ப இங்க என்ன புக்க வச்சு படிப்பீங்க? ஒரு புக்கு இவர் சொல்றதுதான், இன்னைக்கு ஒரு நாள் தான் படிச்சு கொடுப்பாரு, மற்ற நாள்.
I'm going to categorize all the organic reactions that we have to learn in our syllabus under 4 parts, right? So there is no classification like this in your syllabus or somewhere. So this is what I learn, and I'm teaching you that one again for you. And for our convenience, we can categorize them under 4 parts, right? So the first type of organic reactions we are going to learn is carbon atom increasing reactions. Carbon atoms increasing reactions. That means you can see that after this reaction, inside that molecule, that means in that molecule, carbon atoms or number of carbon atoms are increasing. So therefore, we consider that one as carbon atom increase in reaction. And the second type is carbon atoms decrease in reactions. That means carbon atoms are reducing after the reaction. Carbon atoms decreasing reaction. Second type. And the third type, we are going to learn some special conversion reactions. Conversion reactions. See, will you, after learning these reactions, you will understand in order to do a conversion, we don't have to memorize the reactions. We need just practice. Consistency is the key. You have to continually practice these reactions. Then automatically you will see that when you do the past papers, you can do these conversions easily, right? Until these reactions go for your head, you have to practice it, right? Okay, let's see. Carbon atoms increase in reactions, carbon atom decrease in reactions, special conversion reactions. And at last, we are going to discuss reactions related to identification tests. So we have some identification tests to, we have to learn some identification test, right? How we can identify aldehyde ketones, how we can identify alkenes, alkynes. Likewise, we have some identification test. So those reactions also very important in order to do the conversions, right? So these are the 4 types that we have to learn. Okay. Yes. At least there will be 50 reactions to discuss. And I'm going to discuss all the reactions in this organic therapy session. That is my target in this session. Okay, let's see. One by one, we are going to discuss in these sessions. Carbon atoms increase in reactions, carbon atoms decrease in reactions, special conversion reactions, and some reactions related to the identification test in organic chemistry. These are the reactions we have to learn. Quickly write down. Quickly write down these things. Take a CR book. Okay, 200 pages are enough because we are going to do that much reactions and continue to do these reactions. I'm not discussing theories here, right? Reaction mechanisms, okay? Those things I'm not discussing here. We are just practicing the reactions. We can learn the reaction mechanisms and everything in the theory class, okay? Right, okay, done. So the first reaction that we are going to discuss is what? I'm going to discuss with you special conversion reaction number 1. Reactions number 1, that is preparation of Grignard reagent. Preparation of Grignard reagent. You may have heard these things about this one, Grignard reagent, before. What is this Grignard reagent? Grignard reagent is actually playing very, very important role in our syllabus. Grignard reagent. In order to do lot of main conversions, the Grignard reagent is useful. So you have to know, first of all, what does mean by Grignard reagent. So this is related to the next reaction that we are going to discuss. So therefore, Grignard region is very, very important. What is Grignard region? Remember, students, preparation of Grignard region. If you consider alkyl halide, like just imagine Rx, R means we know that alkyl group, X means halogen atom. For the alkyl halide, we are adding magnesium metal in the presence of dry ether. Dry ether, okay? Then it is forming R MgX. Magnesium is coming in between alkyl group and the halogen atom. Then this is considered as Grignard region. RMgX. We can write down the name, proper name for this one as alkyl magnesium halide. Alkyl magnesium halide. Alkyl magnesium halide is a Grignard region, nothing else. Okay. Any kind of alkyl magnesium halide is considered as Grignard region. Can you understand? So why we are adding dry ether here? What is the reason? Okay, we are adding magnesium. We are connecting magnesium with the halogen atom, and it is connected to the alkyl group also. Okay, fine. That is the Grignard region. Why we are adding dry ether? Remember, magnesium is actually highly reactive element. So therefore, magnesium can react with atmospheric oxygen or nitrogen gas, so to form any kind of compound, magnesium oxide, magnesium nitride kind of compounds. So in order to prevent from that one, in order to get the pure magnesium metal, we are using here dry ether as a medium. Then magnesium is easily reacting with alkyl halide to form alkyl magnesium halide, right? So let's consider a few examples quickly. Example number 1. So what is the first reaction we learned today? Preparation of Grignard region under special conversion reaction number 1. Okay. Example number 1, CH3Cl. We are adding magnesium dry ether. Let me write down here De. Then you can understand that is magnesium dry ether, right? CH3MgCl. Yeah, this is Grignard region, right? You may understand. You will understand this thing. How important this Grignard region in conversions in upcoming reactions. And let me consider CH3, CH2, Br. We are adding magnesium dry ether. So this is also Grignard region, CH3, CH2, MgBr. Third one, quickly write down these things with me, quickly. Don't waste time here. We don't have time to waste here. Quickly write down these reactions with me, okay? We are going to do the conversions also. Third one, just imagine we have chlorobenzene. Chlorine is connected to the benzene atom and magnesium dry ether is added. Then what will form? Yeah, it's also forming Grignard region, benzene magnesium halide, chlorine. Quickly. Number 4, CH2Br here, CH2Br. We are adding magnesium dry ether. What will happen? It will form CH2MgBr and here also CH2MgBr. Number 5. Remember students, HCl. For the HCl, we are adding magnesium dry ether. Remember, HCl is not alkyl halide. This is not alkyl group. So therefore, we can consider no reaction between magnesium dry ether and HCl. Number 6. Just imagine acid halide, CH3C double bond OCl. Will it form Grignard region? No. Grignard region means always we should have alkyl halide and magnesium dry ether. This is acid halide. So therefore, no reaction. Because some students consider this also can form Grignard region because in the presence of this chlorine atom. No, it's not possible. Huh? So write down these two and put a cross on the reaction using a red color pen, then that will give an idea that these are not correct reactions. Okay, quickly conclude this one. Preparation of Grignard region. Easy, right? If you have any doubts, put your doubts in the chat box. Okay. Don't try to watch recordings. Okay. Finish the reactions that we learned today from this class. So therefore, don't try to watch the recordings. I'm providing you the recordings, but please try to finish this on that one in the class. Now you have to prepare for the examination. Eh? So you have examination in November, right? How many months do you have? May, June, July, August, September, October. Forget about November, will you? So therefore, you will have only 6 months to prepare for your examination, right? I'm doing this kind of a session for inorganic also. Inorganic in short. I'll let you know about that one very soon. First of all, let's finish this one quickly. Right. Last two reactions. Last to these two reactions. Remember. So who is that? Yeah, Pumi. So this is the thing, okay? Why I'm considering these two reactions are not possible? I told you that in order to form Grignard region, there should be alkyl halide, right? Rx means this is alkyl halide. Tell me whether HCl is alkyl halide. Is it alkyl halide? No, right? HCl is not alkyl halide. Hydrogen is not considered as alkyl group. So therefore not possible. So these are the mistakes that done by students. That's why I'm considering these two are not possible. HCl is not alkyl halide, therefore it's not reacting with magnesium diether to form Grignard region, right? No reaction. Remember those things because these are some mistakes can be done by ourselves, right? And then the next one, CH3 C double bond Cl. What is the type of organic compound? So the type of organic compound is acid halide. You can see the functional group C double bond Cl. If it is acid halide, how it can react with magnesium diether? No, right? Only alkyl halide is reacting with magnesium diether, right? So it is not forming Grignard region. Even though it is forming Grignard region, it's not stable. That's why we consider them as not forming Grignard region, no reaction. Only alkyl halide should be there. Remember, if you want to make a Grignard region, you have to choose alkyl halide and put magnesium diether. That is the rule. Okay. No other compound we can use. Understood, Pumi? Are we done? Right. Next one. Let's write down two more examples. Practice these reactions quickly. So the seventh one is, let me consider a bulky group like CH3CH, CH3I. We add in magnesium diether. Yeah, so it's forming, right? MgI, alkyl magnesium halide. Eighth one, benzene CH2I, CH2Br, and magnesium diether is added. So the answer is CH2 MgBr. Got it? Right. Quickly do this one. So this is the special conversion reaction number 1. So the second reaction that we are going to learn is that is carbon increasing reaction. Okay, carbon increasing reactions. Number one, we learn a special conversion reaction number one. Now we are learning carbon increasing reactions number one. What is it? So here I'm going to react with, I'm going to talk with what? Reaction of aldehyde and ketones with Grignard reagent. Okay. Okay. Reaction of aldehydes and ketones with Grignard reagent. Students, now you know what is Grignard reagent, right? Because in the previous reaction, we learned how to prepare Grignard reagent. Grignard reagent is prepared by adding magnesium for alkyl halide. You know that. Now this Grignard reagent is reacting with aldehyde and ketone. This is also very famous reaction. Let's learn how it reacting. Okay. Quickly write with me. Finish these things. Topic: carbon increase in reaction number one. Reaction of aldehyde and ketones with Grignard reagent. Quickly. Okay, just imagine we have aldehyde or ketone. So for this one, we can take aldehyde and ketone both. Let me consider this one is aldehyde or else ketone. If it is an aldehyde, what should be? C double bond OH. If it is an ketone, we can put here R dash. So I wrote both here to identify aldehyde or ketone both out. Right. Now, students, remember, here we are adding a Grignard region for this aldehyde or ketone. Let's see what will happen. So what is Grignard region exactly? I'll write down the Grignard region as, so that is also alkyl group. We can put that one as R double dash, okay, R double dash MgX, R double dash MgX. Okay, right. Now what will happen? Remember, students, the thing is R double dash and MgX. This is the Grignard region. This Grignard region is, I am not talking about the reaction mechanism here, right? I told you at the beginning, I am not discussing reaction mechanism. What is reaction mechanism? Reaction mechanism means how the reaction is proceeding, how the reaction, we can explain the reaction using the reaction mechanism. We can explain the polarization, how the bonds are breaking, how the bonds are forming, how the nucleophiles are connecting, how the electrophiles are connecting. I'm not discussing those things here. I want you to understand what is the reaction. That's all. Look at this one. So therefore, look at my simple explanation. This is alkyl halide, Grignard region, alkyl magnesium halide. So actually we can identify this Grignard region as two groups, alkyl group and magnesium halide. Okay, what are they? Alkyl group and the magnesium halide. Therefore, I'm going to break this bond from here, R double dash and MgX. So remember, this R double dash group is connecting to this carbon atom in this way. Remember that one. Okay, this is the way that Grignard region is reacting with aldehyde and ketone always. R double dash alkyl group is connecting to the carbon atom. Then what should happen to the MgX? MgX is connecting to the oxygen atom. MgX is connecting to the oxygen atom. So, but oxygen is satisfying the octet. So, therefore, how oxygen can form another bond? Yeah, we have to break this bond, right? Carbon oxygen double bond is there. We have to break one of the bond and then carbon also can form another bond. So if I write down the product here, what should be the product, students? Look at this one, how easy these things are. Carbon H slash R dash, and here we have oxygen. What will happen? MgX is connecting here. MgX is connecting here. Then R double dash group is connecting to the carbon atom. Okay, so how these things are connecting like this? What is the reason? Those things actually, as I mentioned, we are discussing these things in reaction mechanisms, organic theories. Now just you remember the reaction. What is the reaction? That's so. Okay, look at this one again. We had the Grignard region. I identified the Grignard region as two groups, R double dash alkyl groups and magnesium halide. This alkyl group is connected to the carbon atom, and magnesium halide group is connected to the oxygen atom by breaking this carbon oxygen double bond. That's all. Can you understand? Do you have any doubts? Do you have any doubts related to that step? Anything? That's very easy, no? Anything? Right. Okay. Then, as the next step, we are adding H3O plus for this compound. What is the second compound that we are adding? H3O plus. Look at this one. Students, look at this one. Very easy. R carbon oxygen, R dash, and here we had MgX, and this is R double dash. By adding H3O plus, what will happen? This compound is reacting with water. Okay, how it is reacting with water? Actually, this OMgX group is reacting with water in this way. We know that actually in a water molecule, we can identify H and OH group. We can identify hydrogen and OH group in water molecule. Therefore, what will happen? This hydrogen is connecting to the oxygen atom by breaking these two bonds. This one and this one. OH is connecting to the MgX, right? These two bonds are breaking. Then what will happen? OH is connecting with MgX, and this hydrogen is connecting to the oxygen atom. Then what is the final product you can see? R, C, and here we have that alkyl group came from the Grignard region, R double dash, and here we have oxygen and hydrogen. Students, by adding Grignard region, where we have ended this compound? We started from aldehyde and ketone. Now, what is the final product we got? What you can see here? What is the type of compound? Anyone? This is famous reaction, okay? Alcohol. Yes, this is an alcohol, right? So we have started from aldehyde or ketone. By adding Grignard region, now we have ended up with alcohol. Can't you see that number of carbon atoms have increased? Because this R double dash group is connected to the carbon atom, means R double dash means alkyl group. Carbon atoms are increasing. Therefore, we can understand that this is carbon increase in reaction, and specialties. We are starting from aldehyde and ketone. Now we have ended up with alcohol. These are known as what? Conversions. So this is a simple conversion. We are starting from an organic compound and we ended up with another organic compound. So that is a conversion. This is a single step conversion, right? Okay, this is it. That's all. Started from aldehyde ketone, added Grignard region, R double dash is connecting to the carbon, MgX is connected to the oxygen. We have this kind of a product. Secondly, we are doing the hydrolysis reaction. Hydrolysis means adding water to react with water. Then what will happen? Water molecule can be identified as H group and OH group. Hydrogen is connected to the oxygen, OH is connected to the MgX. Then one more thing I want to remind you. So what is this MgX? What is it? So that is the byproduct. Byproduct of this reaction, we can consider that byproduct of this reaction is MgX OH. Okay, so that is the byproduct. Try to understand. This is very, very, very easy. These are symbols now. In the next one, I'm going to discuss a proper example. Quickly write down these things. If you can use color pens, yes, that will be a good thing for you. Okay, are we done? Quickly, yeah. Right, okay. Let's move for an example. Look at this. Example number 1. We have an aldehyde CH3C double bond OH. And we are adding Grignard region CH3 MgBr for this compound. Okay, very easy. So let's try to write down the product. So what should be the product? As I mentioned you, this is the alkyl group, this is the magnesium halide breaking here. CH3 is connecting to the carbon atom and MgBr is connecting to the oxygen atom. And then the product should be CH3, OMgBr, H here, and CH3. Got it? After adding H3O plus, what will happen? After adding H3O plus, hydrogen is connecting to the oxygen atom in this way. Then it's forming CH3, CH, CH3OH. Very easy. You can see that OMgBr group has been converted into OH by adding H3O plus. See how easy these things are. First of all, you have to practice these things. Okay, no need to panic of these things, right? You have to practice. Now you know the method, practice it. Second one. Second one, let me consider in this way. CH3, C double bond OH, CH3, CH2, MgCl in this Grignard region. So this is ethyl magnesium chloride. So what will happen? This bond is breaking. Okay, oxygen is connecting to here. This one is connecting here. CH3, OMGBr, H here, and alkyl group, ethyl group is connecting here, CH2, CH3, and H3O plus is added. What will happen? When H3O plus is added, this will be converted into OH. OMGBr will be OH. Right? Always we are ended up with alcohol. Third one, CH3, C double bond O CH3. And here we have benzene magnesium chloride. So what should happen? So here the bond is breaking from here. Then benzene ring is connecting to the carbon atom. MgCl is connected to the oxygen. So the product is CH3, O MgCl, CH3, and here benzene. After adding H3O plus, what will happen? OMG group is connecting, converting to OH. It's very easy. Quickly do it. Example number 4. Now, if we consider the Grignard region here, MgCl, same thing, right? We don't have to worry about it. That is the same thing. We adding CH3, C double bond OH here. So as I mentioned you, what will happen? So the CH3, CH2 group is connecting to the carbon atom, and MgCl is connecting to the oxygen. So therefore, the product is CH3, CH2, OMGBr, OMGCl. After adding H3O plus, this way. So that is the fourth one. If you have any doubts, put your doubts in the chat box quickly. Number 5. Let me consider benzene magnesium bromide is reacting with methanol. Methanol is the simplest aldehyde with one carbon atom. Okay. And so that is also same way, right? So the bond is breaking here. Benzene ring is connecting to the carbon atom from here, and MgBr is connecting to the oxygen. So therefore, OMgBr H, and here we have benzene. After adding H3O plus, what will happen? After adding H3O plus, OMgBr group is converting to directly OH in this way. See how easy these things are. Number 6. Number 6, CH3, MgI, Grignard region. We are adding acetone. If not, we can say this is propanone. We are adding this compound. So as before, as I mentioned you, the bond is breaking from here. So carbon is connecting to this one here, and oxygen is taking Mg. So therefore, the product should be CH3, CH, CH3, C, OMgBr, CH3, CH3. Doesn't matter the positions of the carbon atoms, they can be changed, right? Doesn't matter. So here CH3, here two CH3 groups. Now I have put them here. Doesn't matter. It's okay. So after adding H3O plus, what will happen? After adding H3O plus, OMgBr group is converting to OH. Very easy. Those are the 6th one. Sometimes you have to think revise also. In the examination, they're expecting you to think revise. Okay, that means they will give you the final product and the regions that they have added. You have to obtain the compounds that we have used from the initial one and the next intermediate. Okay, so let's try to go for the revise from the next exam. I'm discussing many examples under this reaction because this is the, I can say that this is the most important reaction, right? Because if you analyze the past papers and everything, and every year actually there is a conversion related to the Grignard region. By doing past papers also, you can learn reactions. Okay, conversions, try them. After this organic therapy sessions, that means these conversion sessions, you can try them all. At least you have to practice past 10 years before go for the examination. So now you are facing for the examination in 24 this year. So therefore you have to choose from 2014, right? 2014 to 2023, past 10 years, you must do them. Right. If you have any doubts, tell me, right? Number 7. So in the 7th one, we are going to revise, okay? So you have to choose what are the compounds appropriate there. So this is CH3. We have to think revise how we can do this one. Anyway, we know that OH group has been formed by adding H3O plus, because previously we had OMG, we are OMgCl. Definitely this one should be OMgCl, isn't it? That's very easy now. Yeah, that is easy. OMgCl converted to OH, that's all. Now, what is the aldehydo ketone that we started this reaction before at Grignard region? We have added the Grignard region CH3, CH2, MgCl. We have added it. Before we add that one, what is the compound we had? Think about it. So you can see that, look at this one. This CH3, CH2 group came from the Grignard region, right? Can you see that? For this compound, CH2, CH3 ethyl group is came from the Grignard region. So if it is came from the Grignard region, so what are the remaining ones? Our remaining ones is the aldehyde. We can take CH3, carbon, CH3, and oxygen. Forget about MgCl, because MgCl also came from the Grignard. So that's how you think revise. Okay. Try to understand. Here we had CH2, CH3, which is came from Grignard region. We have MgCl, came from the Grignard region. Then the remaining ones are the initial organic compound. That is a ketone. Okay, let's try the eighth one. In this way. And here we are adding benzene, magnesium bromide. Yes. So you try them before I try these things, okay? Ninth one. Let's move for the eighth one. So before we had H3O plus, definitely we had OMgCl. OMgBr, okay, because here Br. Then carbon atom. So all of them are phenyl compounds, right? Phenyl group in this way. Right. Now think about in this way. MgBr came from this compound, Grignard region, and one benzene ring came from Grignard region. So then what are the remaining ones? This phenyl ring and the below one, carbon and oxygen. And then the initial compound was two phenyl rings connected to the carbon atom and the carbonyl group, C double bond O. A ketone. That's a ketone. Very easy. Do with me quickly. Practice it. Until you get these things into your mind, into your head, you have to practice these things. That's the way. Try the ninth one. Look at the ninth one. We have alcohol. We have an H3O plus, therefore CH3, CH, OMgI, CH2, CH2, CH3. Okay. And we know that MgI came from the Grignard region. And this bulky group, this is propyl group because 3 carbon atoms. So this group is propyl one. So therefore, what is the remaining ones? So the remaining ones are CH3, C double bond OH. That's it. Okay. Ninth one. So let's move for the 10th one. Let me consider the compound in this way. Right. Look at this. 10th one is easy. We can do this. H3O plus. Before at H3O plus, definitely the compound is OMgBr. We can take OMgBr or MgClO. I doesn't matter. CH2, CH3. and here CH. Now they have added a ketone here. That means initially they have started from Grignard region. So we can see that carbon oxygen group is there. So this is it. And CH3, here that's CH3. And CH2, CH3, yeah. So they are belong to that ketone. So what are the remaining ones? The remaining ones are benzene ring and MgBr. Then that is the Grignard region. That is the Grignard region they have used. That's easy, right? Very easy. Right, okay. Now students, we have discussed 10 reactions. In organic conversions, we can use these two steps together. But there is a condition. What is that condition? We have to put numbers. And you have to show which step is the first one and the second one. For example, if I consider the 11th one as CH3, C double bond H. So you should be able to get the answer directly by now, right? So I'm adding the Grignard region CH3 MgCl. So that is the first step. That is the first region you're adding. And secondly, H3O plus. We can write down that one as H plus slash water. Now you should be able to predict that one directly because we have discussed some reactions too. So what is the compound? CH3, CH, write down that one as it is. And this CH3 is connected to the central carbon atom from the Grignard region. The double bond is converting to OH. Easy. We started from aldehyde. Now we have ended up with alcohol, which has a larger number of carbon atoms than the aldehyde by adding Grignard region. So this is very useful in organic conversions. Very, very, very important. Right? 12th one. Let's try it. 12th one. Benzene, C double bond CH3. Firstly, we are adding CH3, CH2, MgBr. And secondly, H3O plus. So what will happen? That carbonyl group is converting to OH, CH3, and the alkyl group of the Grignard region is connecting to this compound, CH2, CH3. That's all. Easy. Thirteenth one. I'm starting from a Grignard region. and I'm adding CH3, CH2, C double bond OH, secondly H3O plus. So what will happen? CH3, CH2, O, H hydrogen here, and the alkyl group of the Grignard region is correct into the carbon atom. That's okay. Last two reactions. Last two reactions that I'm going to discuss under this topic, 14 and 15. 14 and 15, let's go for the reverse. How about this? We're adding CH3, C double bond of CH3 acetone. And secondly, H3. Okay. And the product is CH3, COH. CH3, CH2, CH2, CH3 in this. Okay, so try to get the initial product, initial reactant. Try it. Here, I have taken benzaldehyde, second H3O plus. So the final product is this one. What is the initial compound that they have used? Try to understand. Do it quickly. 14th and 15th.
Sir, you are muted.
Oh, sorry. Now you can hear me, right? Right, okay. Now you can hear me, right? What about these two now? As we mentioned, right, okay. Look at this, Anil. So here we have a ketone. So inside this ketone, actually, we can see two alkyl groups, CH3, CH3 groups. So we know that these two CH3 groups came from this compound. So then what is the additional group here? CH2, CH2, CH3. That additional group is came from the Grignard region. So that's why I wrote there CH3, CH2, CH2, CH. And here, again, look at this one. The aldehyde that we have, benzaldehyde. In benzaldehyde, we have the phenyl ring, hydrogen atom, and the carbonyl group. So the additionally added compound is CH2, CH2, CH3. So that is Grignard region. Okay, that's all. Carbon increase in reaction number one, reaction of aldehyde and ketones with Grignard region. We have learned special conversion reaction and carbon increase in reaction number one. Do you have any doubts related to these two reactions that we learned? So we learned today these two reactions are very, very important reactions. Okay, you will understand when you go for the conversions. Any doubts, anything? Please raise your hand who understood everything. Okay. Right. Now let's go for an exercise, a simple exercise. Related to these two reactions we learned. We learned two reactions, formation of Grignard region, and the second one is reaction of aldehyde ketones with Grignard region. Okay, so using these two reactions, let's do some practice exercises. Okay, right. Number one, do with me quickly. CH3, CH2, Cl. You have to write down the compound that we have to add to convert that one on the arrow. On the arrow, you can write down the compound we have to add. Okay, CH3, CH2. Second one, third one, CH3, CH2. PR. We are adding magnesium triether. What is the compound can form? Then we are adding acetone. Compound H3O plus is added. Final answer. First one, look at the first one. These things are very easy. In order to convert this one into a Grignard region, alkyl halide Grignard region, what is the compound we have to add? Magnesium triether. Do with me. And then we have added aldehyde or ketone, right? Try to understand CH3CH2 here, CH3CH2, MgCl here, MgCl here. Then what are the additional compounds? Carbon connected to two hydrogens and oxygen. Yes, we have added methanol, aldehyde, right? And here we know that we have to add H3O plus in order to convert OMgCl into OH. Second one, we have to add magnesium triether. And MgCl and the phenyl ring. So here phenyl ring, MgCl. So then what are the additional things? CH3, C double bond O, H. Easy. Definitely here this should be converted to alcohol by adding H3O plus. Quickly finish this one. Magnesium triether is added for the alkyl halide. Then it is forming CH3CH2 MgBr. We have added ketone. What will happen? As we mentioned, MgBr is connecting here. Alkyl group is connected to this carbonyl group, carbon atom. OMgBr, CH2CH3. Quickly finish this one. If you have any doubts, let me know. Tell me, right? So what are the uses of organic chemistry? Okay, we have a question from who? Piumi. Organic chemistry කළා තේරුම් නැහැ වගේ වට හිතනවද? එහෙම එකක් නැහැ හරි. දැන් ඔය දැන් අපි කතා කරන හැම compound එකකම අපි එදිනදා ජීවිතයේදී අපි මුණ දෙන අපි පාවිච්චි කරන හැම දෙයකම organic molecules තියෙනවානේ. උදාහරණයක් විදිහට ගත්තොත් ඔයගලන්ගේ ගෙදර ඔයා කුස්සියට ගිහලා බලන්නකෝ කුස්සියට ගිහලා බලුවත් organic chemistry තියෙනවා. gas cylinder ඇතුලේ මොනවද තියෙන්නේ? Propane, butane. Inside the gas cylinder, LP gas means liquid petroleum gas means propane and butane. A mixture of propane and butane. Panadol is an organic molecule. We go for the petrol shed. Petrol is an organic molecule. Octane. එතකොට organic දැනගන්න ඕනේ නැද්ද අපි? You can ask a question like this. So why we are doing these organic conversions? මේව කරන්න මොකද? මේව කරන්න ඉතින් exam එකට. මේව exam එකට අහනවනේ. ඒක නේද මේව exam එකට කරන්නේ. තේරුණාද? මේව පණ දාගෙන කරන්න ඉතින් මේව exam එකට අහන්න. Organic chemistry ඉගෙන ගන්නේ you should know the things that we are facing in day to day life, right? Kerosene, right? So the paints, so this ink, everything is a organic molecule. Yes. අනිවාර්යෙන් දැනගන්න ඕනේ. Yes, we must know. That's a good question. Students, you can learn organic chemistry even in the university, right? You can go for chemistry special degree, right? So we can you can learn organic chemistry further if you are interested in that one. So this is not organic chemistry. මේ conversions කරනවා කියන එක නෙමෙයි organic chemistry කියන්නේ. Organic chemistry කියලා කියන්නේ ඊට වඩා දේවල් ගොඩක් දේවල් තියෙනවා, right? So I also know a little. Understood? So therefore there are so many things. Honestly, I have to say that in university actually I have learned a lot of things. I can't remember, probably in the second year of the university I had a course known as organic chemistry. So and there we learn a lot of things that we didn't discuss in here. So if you are interested, you can learn them, find it. Okay, now you have resources, you have Google, YouTube, ChatGPT, everything is there, so you can find it. Now knowledge is actually what freely available everywhere. Okay, right. Fourth one, so the fourth one, let me consider CH3CH, CH3Cl, and here we have added CH3 C double bond OH. And then we are adding H3O plus. So what is the first of all, I'll put the questions and later we can discuss about the answers, right? Quickly do them. In the fourth one, yeah, we are adding magnesium diether. Then it's formed Grignard region MgClCH3. And we have added ethanol. So what is the compound? CH3, CH, CH3, MgCl, HCH3. After adding H3O plus, this OMgCl group is converting to OH. Go for the fifth one. In the fifth one, actually, we need final product, no? I'll give you the final product as okay, now you can do that one. Do the fifth one. That's very easy. So before we had H3O plus, we had what exactly? OMGBr, right? And here CH3, CH2. And CH3, CH2 here, hydrogen here. So what is the Grignard region we have? They have added. So the Grignard region is CH3 MGBr, isn't it? Okay. CH3, CH2 came from this compound, hydrogen came from this one. So the remaining one is CH3 MGBr. So CH3 MGBr came from CH3Br when it is reacting with magnesium diether. Formation of Grignard region using alkyl halide. So that is the fifth one. Quickly, huh? Let's do two simple conversions. Let's see whether you can go do that conversions using only these two reactions. May reactions they vitarap conversion right? Body conversion. Later we are going to learn a lot of a very big big conversions. First of all, let's start from the simple ones. Okay. Sixth one. Magnesium dry ether is added to a compound, and that compound is reacting with methanol to form this. When we add H3O plus, final product is, so this is very interesting, okay? Just think, use your brain and get the answer. Specialties, two alcohol groups are there. Can you see that? OH group here as well as here. So this is diol. Then try to understand what kind of a compound that we had initially. The initial compound is very interesting. Try to get it. Okay. So tell me, did you get the correct answer? Anyone? Raise your hand who got the answer. Correct one. Who got the answer for this one? Okay, Pumi, good, very good. Asma, Sarina, Manugi. I joined a couple of minutes ago, sir. Oh, Asma, that means you are too late. It's okay, right? I'll give you the recording. Later, watch the recording. Okay, Asma. And I told you for the 25 batch, this is not compulsory. Okay, you don't have to attend for this session. This is extra knowledge. Again, in the next year, we are doing this one for you all. So this is for the 24 batch, right? So therefore, no issue. Don't take that one too serious. Okay, Asma. Right. If you go for this one, look at this. We have added H3O plus. Since we have added H3O plus, 2OH group is there. Then you have to understand 2-OMGBr is there. OMGBr. Oh my God. That means there are two terminals, right? Connecting that MGBr. It's okay, fine. We know that this is the aldehyde we have added. Then what should be the Grignard region we had earlier? So the aldehyde is CHOH, methanol. Can you see that? Here also we have aldehyde group, and here also we have aldehyde. Then what are the remaining ones? Benzene ring, magnesium bromide, and down also we have magnesium bromide. Specialty is we have two terminals of Grignard region and two methanol molecules are connecting to that two terminals. Therefore, the initial compound is, before we add magnesium ether, that is dibromide in this way. Okay. We can say that Otho para positions, right? Para positions. Para bromobenzene. Two bromine atoms are. Okay, let's do now simple conversions. Before we go for the next reaction, let's do two simple conversions. Very simple, huh? Number one, you are starting from chlorobenzene and you have to go for CH2OH connect to the benzene ring. So just two steps enough, not more than two steps. Just two steps are enough. Next one, let me give you like this CH3 CH2Br. Quickly do it and raise your hand who did these conversions. Just two steps, enough. So these are the first conversions you are doing in this class, right? So try to do it. You have learned only two reactions, right? You have to use them, that's all. What is it? right? Hands up, how many of you did these two conversions? Raise your hand. Devmini, good. What about the others? Sarina, Asma. Yeah. Piyumi, you also did. Okay. Right, okay. Now look at this one. This is very easy. First of all, I'm adding a magnesium dry ether in order to form Grignard region. Then what it will form? Benzene magnesium chloride. Got it? And here, directly we can go for this one by adding methanol, HC double bond OH, secondly H3O plus. Just two steps. Just two steps are enough. Got it? CH2OH, that means we have added only one carbon atom. So therefore the aldehyde with one carbon atom is methanol. HC double bond OH and H3O plus is added, then it is converted to CH2OH. Easy, easy. Look at the second one. In the second one, so here also I'm forming magnesium dry ether is added to form Grignard region CH3, CH2, MgBr. I have added this one. So from here to here, we can add benzene magnesium chloride and secondly H3O plus. That's all. Sorry, magnesium. No, we have Grignard region. So therefore, the compound is benzaldehyde. Benzene C double bond H. Secondly, H3O plus. Okay. So the Grignard region is providing this alkyl group MgBr, and benzene ring and the hydrogen is the one who came from the aldehyde. That's all. If you have any doubts, tell me. This is very easy. Okay. Right. Okay. Now let's move for the next reaction we have to learn. Next reaction is special conversion reaction. Number 2. Special conversion reactions. Number 2. Okay. What is it? Alcohols to alkyl halides and carboxylic acids to acid halides. Okay, so these two are the conversions. Let's see. First of all, look at this one. Alcohol to alkyl halide. Alcohol means R OH group. We can add here PCl5 or PCl3. PCl3. Then what will happen? This is converting to RCl. OH group is converted to chlorine. This is very, very important. Right? In conversions, this is very, very important. Students, not only chlorine, but we can connect bromine atom also. We can add PBr3 also in order to convert this one into RBr. That means alkyl bromide. Okay, so let's consider a few examples. Very easy. This is the way that we can convert alcohols into alkyl halide by adding PCl5, PCl3, or else PBr3 also possible. Examples, number one, let me consider methanol reacting with PCl5. So what will happen? CH3, Cl4. So the byproduct of POCl3 and HCl. So these byproducts are not that much compulsory in conversions, but this is the main product. Okay. Second one, let me take CH3, CH2OH, ethanol. We are adding PCl3 for ethanol. What will happen? It will form ethyl chloride. So here the byproduct is H3PO3. Okay. So that is the byproduct. So likewise, we can add PBr3 also. CH3, CH3OH. We can add PBr3 to convert this one into alkyl bro in this way. Okay, quickly write down this example. Starting from alcohol, ended up with alkyl halide. Very easy. So forget about these byproducts. These things are not that much important. Just think about the main product. OH converted to Cl. OH, Cl, bromine. Likewise, we can add these PCl5, PCl3 for where? Carboxylic acids also. Quickly finish writing. Right, done. Let's see how we can convert carboxylic acids into acid halides. Let's see that one also. Same thing, right? Same thing. Carboxylic acid, we know that functional group of carboxylic acid is C double bond OH. We can identify a carboxylic acid using the C double bond OH. So when you add PCl5O, PCl3 again, what will happen? So this will be converted to acid halide, C double bond OCl. So this is acid chloride, right? So here we have carboxylic acid. We have started from carboxylic acid and ended up with acid halide. So you will see how important this in conversions. Examples. Let's start from the fourth one. Benzoic acid. We add in PCl5. What will happen? Will form C double bond Cl. Number 5. CH3CH2 C double bond OH. Propanoic acid. We add in PCl3. So what will happen? That OH group is converting to Cl. That's all. Remember, students, phenol cannot react in this way. Even though phenol has OH group, it cannot react with PCl5O, PCl3 to give a product. Why? The reason is this oxygen is giving electrons to benzene ring, and this oxygen carbon is forming a partial double bond. Because of the stability of that bond, so this is actually not forming Cl. So chlorine cannot connect to that benzene ring because of the stability of the anion. Actually, after removing H plus, it's forming O minus a phenoxide anion. So that phenoxide anion is stable. Therefore, it's not forming chlorobenzene. So therefore, no reaction when we add PCl5 for the phenol, even though there is a OH. Try to remember, okay? So these are the things you have to remember, because in conversions, by mistakenly, you can put here PCl5 for the phenol. Then is that correct? No, you can't continue the conversion. That's wrong. Quickly do this one. Right, okay. Next example. Seventh one. So this is a combination of previous examples also, previous reactions that we discuss. So how we can do this conversion? That means we have to add the regions in each step. What are they? First one, OH is converting to Cl by adding PCl5. Then it is converted to Grignard region, magnesium diether is added. Then for this one, they have added aldehyde. CH3 came from the Grignard region, MgCl came from the Grignard region, and the remaining ones are these. That means they have added methanol. And here H3O plus is added. PCl5 is added here again. And here magnesium dry ether. And what is the compound here? CH3CH2 came from here. MgCl. So therefore remaining ones are we adding ketone, aldehyde, CH3C double bond OH. Secondly, H3O plus. First and the second one. Very easy, right? Little by little, we are increasing the length of this reaction series. Quickly finish this one. Right. Now let's move on the next example. Example number 8. Look at this one. Here, we have added CH3MgBr. Okay. And H3O plus, PCl5, magnesium diether. And we can see that this is the Grignard region. In that Grignard region, we can see this group. And MgCl group is this one. And the aldehyde we have added is methanol. And H3O plus is added here. PCl5 is added again. So same thing, right? We are repeating the same thing because we need to practice these things. That's why we are repeating the same thing. Okay. So these are the reactions. Quickly do it. Right. Okay. Okay, students. Today we discuss three important reactions in organic reactions. Okay. So first one is uh, preparation of Grignard reagent, special conversion reaction number one. Secondly, we learned that carbon increase in reaction number one, aldehyde and ketones reacting with Grignard reagent. And the third one that we discuss is this one, special conversion reaction number two, alcohols to alkyl halides and carboxylic acid to acid halides. Right. So, do you understand what did you learn today? Do you have any doubts? Anything? Please raise your hand. Who understood everything that we learned today? Please raise your hand. Who understood the things that we learned today? Okay, good. Right. Okay, I'm going to give you a small homework before I'm ending the class. I'm going to give you two conversions, right? So do these two conversions as a homework. So this is from the things we learn. I'm discussing this one in the next week class. Number one, do the conversion CH3 C double bond OH, which means ethanol going for CH3, CH3. So the maximum number of steps are 1, 2, 3, 4. 4 steps. Not more than 4 steps. Huh? Not more than 4 steps. That is the condition. Second one, bromobenzene, do the conversion. If you can do this conversion after the class, that is good. Send me a WhatsApp message. I'll check whether your answer is correct or wrong. Not more than 4 steps. That is also 4 steps. Okay, do these 2 conversions as a homework. And in the next week class, I'm going to discuss these 2 conversions again. And we are going to learn some more reactions. Okay. If you have any doubts again, theory class එකේ පියුමි මම isomers විතරයි කරලා තියෙන්නේ. Isomers වෙනක විතරයි. Organic theory one තාම කරලා නැහැ. අපි පටන් ගන්න. Right? පියුමි. Right. Anything else? Any doubts? Do you have any doubts? No, right? Quickly copy down this homework. In the next week also, we are discussing 3 or 4 reactions related to this one and practice them. So my theory class is on Friday. Maybe Friday. Okay. Do these 2 conversions and send me a message, WhatsApp message. I'll check whether your answer is correct or wrong. Okay. So try that one. Now you just learn these things. So therefore, anti urna gamma try kala dan. Iwarak kala dan. Podi deyak තියෙනවා. ඔයගන්ට හරියට කරා නම් මම හිතන්නේ විනාඩි දෙකකින් වගේ ඉවරක් කරන්න පුළුවන්. after this. Right. Okay. Then, if you don't have any doubts, I'm going to wind up the session. So, first of all, tell me, was it useful, the session that we did today? Did you understand everything that we discussed? Maybe when you can Greek, then yes. Understood. What about the others? Clear. Okay. Good. Sarina, Devmini, understood. Okay, good. Madhuri. Okay, right. Okay, good. Right. Okay, then I'm going to wind up the session. Let's meet on the next Sunday, sharp 2 p.m. Until then, bye. Have fun. You practice these reactions again and again. Okay. Let's meet on the next week class. Bye.